All right, I just wanted to go over basically all the topics that we've covered so far for Unit 2. There's a lot on this quiz, so I just wanted to kind of show you a sampling of the types of questions that you're going to be asked, okay? So I've broken it down into these 6 sections. So the first section is your parent linear functions. The entire first page of the quiz, you will have to write the equation of the parent linear function, right? So I've listed here, right? The first one is the parent linear function. You must know his equation is y equals x. You must know what his graph looks like. You'll also be filling in a table. Remember, you can always type this into your calculator if you need to. You will also have to identify the domain, the range, and the x and y intercept of each of the parent functions. Now, I'm not going to sit here and write this all down right now, but it is in our notes. If your notes are not complete, then go to the completed notes in Canvas, and you can look at them there, right? But you have to know how to write his equation, fill in the table, draw the graph, and domain, range, and the intercepts. Same thing with our parent quadratic function. His equation is y equals x squared. His graph is U-shaped, right? Remember, we call that a parabola. You must also know his domain, range, and intercepts. And lastly, the parent exponential function, right, is the equation y equals 2x is the parent function. Remember, he is a curve that swings upward. He also has an asymptote. If you remember that word with the analogy of me trying to reach the cabinet and decreasing my distance by half every time, and I'm never ever going to get there. So remember, the exponential function is never going to get to that x-axis. So remember, he's never going to reach or touch the x-axis. So he has no x-intercept, right? But you need to know his domain and range as well. Okay, so you need to know all 3 of those. That is the entire front page of your quiz. Okay, then after you write down all your parent functions, then we want you to be able to analyze what function family other graphs come from, right? So example that I have on section 2 here, right? You should be able to look at a graph and ask yourself, this graph, he's not a parent function, clearly, but what family does he belong to, right? Which one of these is his parent, right? And so clearly he's not linear and he's not quadratic. So this is an exponential function, right? That is the family he belongs to, right? He's not the parent exponential function, right? But he's definitely in the exponential function family. So you need to be able to identify that. And you also need to be able to identify his domain and range and intercepts, okay? This next graph, right, clearly that is a line, so he belongs to the linear function family. Again, he's not the parent linear function, right, but he is clearly a graph of a line, so he is in the linear function family, right, and you also need to be able to identify his domain and range and intercepts. Okay. And then lastly, we have this lovely U-shaped graph. Remember, we call that a parabola. So clearly this graph is a member of the quadratic function family. Again, he's not the parent quadratic function, right? But he is in the quadratic function family. He's just been moved around the graph a little bit. Okay, and you should be able to identify his domain and range and intercepts. Okay, so just kind of keep that in mind. All right, this next section is our function notation, right? And I put an example of each of them. So if f of x is negative 3x squared minus 6, so here's our function. Please remember, f of x is just a fancy way of saying y, right? That's all that is. So then it says, what is f of 4? Well, remember, right, function notation is f of x. So what they're asking you is to go to, I don't want that, Heather, go to the f function, which is right there, and plug an 4 in for x, right? They're telling you what the x value is, right? So we're going to go back over here, f of 4, right? I'm plugging the x of 4 in, and equals negative 3, 4 squared minus 6. Sorry about that. And then your job is just to, and you can just type it in your calculator if you want to, right? You're just simply evaluating the expression or the equation on this side once you plug the 4 in for x. So we're going to say f of 4. And if we type that in, what's that going to give us? 16, negative 48. All right, so negative 54. Okay, and that's your final answer, right? Okay, so that's when we, sorry, let me erase that right there. And box my answer. Sorry about that. And that's your final answer. So remember, what that's telling us is that, and again, this is not part of the answer, I'm just side-libbing, kind of like what we were talking about in class. This means when we put in a 4 for x, we're getting out a negative 54 for the y, right? So they gave us the input, and we're asking us to find the output, okay? Now on this one, the next question, it's completely different, right? Because on this one, it says if f of x equals 4x plus 3, find x. So you're solving for x if f of x is negative 25. So this is the output, right? This is the y, right? So we're going to be taking that negative 25, and we're actually plugging that in. We're not plugging it in for x. We're plugging it in for f of x. Okay, it's the reverse of number 3, the question we just did, right? So they're giving us the output, right? So essentially when we're all done, here I'm going to go ahead and draw my little arrow like we just did a second ago, right? At the end of the day, what they're saying is when I get out a negative 25, right, what was the x that got me there, right? So it's the exact opposite of the question that we had before. Okay, so we just need to do the math. So we're going to plug a negative 25 in for the f of x, and then we're going to bring down the 4x plus 3 so that we can actually solve this little two-step equation for x, right? So clearly this is just little two-steppers, so we're just going to subtract 3 from both sides, which is going to give us negative 28 equals 4x. And then we want to divide by 4 on both sides. So we are going to get x equals negative 7, right? And so that tells me that I'm going to erase my little question mark over here, right? This tells me that input of negative 7 is the only thing that can produce an output of negative 25 that they told me in the beginning of the problem. Okay, again, I just want to reiterate, I'm going to kind of erase this. Up here, right, it was the exact opposite. Sorry. They gave us, oh my goodness, I'm sorry. I don't know what's wrong with my, yikes, my eraser. Sorry about that. They told us the x value. They gave us the input, and they were wanting us to find the output, right? So our question mark was right here. Right, and then when we solved for the y output, right, that was our negative 54 that we plugged in right here. Okay, so just recognizing that these questions are the opposite of one another. Okay. All right, the next section really quick is discrete versus continuous, right? Remember, discrete means that when you graph it, you're only using dots because you can't, the topic that you're talking about can't exist in fractional form, like halves and thirds and 1/4 and 2/7, right? I can't have any fractional or decimal versions. I can't have all the decimal or fractional versions, right? So the first one says the number of pencils I can buy depends on the amount of money I have, right? And so clearly when I say the word number, right, a number of pencils. So you got to ask yourself, can I go to the store and buy 3.25 pencils? Can I walk in and buy 4 1/7 of a pencil? Right? So when I go to the store, I'm only buying whole pencils. I'm not buying fractional pencils or decimal values of pencils, right? So the fact that I can only buy whole numbers of pencils makes this discrete, right? Because continuous means my graph would be a continuous line or a continuous curve where I don't pick up my pencil and I'm including all the infinite points, okay? So the next one says the height of a candle depends on how long it is lit. Well, obviously, you know, the longer a candle is lit, the lower the candle goes. So it gets shorter and shorter and shorter, right? So the question is, does the height of the candle, does it only exist in whole numbers? Or can the height of a candle be 3.5 inches tall? Or 3.25 inches tall? Or 3.02 inches tall? And yes, of course it can, because height, right, is a continuous measure where it can exist on any fraction or decimal value. Okay, so this is going to be a continuous graph. Okay, all right. The next section on the quiz is going to be about our arithmetic and geometric sequences. So it's just important that you just understand the set of directions that are given to you, right? You guys loved this day. You thought it was super easy, so I'm hoping you remember what we did. So remember, when we talk about sequences, right, we're just talking about a list of numbers that follows some pattern, right? So this one says if a sub 1 equals -3. Now remember, that is just fancy talk for just saying the first term. That's why there's a 1 right here. The first term in the sequence is -3, right? That's all that means. They're just telling me what the very first number is so I can actually get the ball rolling. Then it's up to you to go look at the rule and figure out what the rule is trying to tell you. And the only thing that this rule is telling us is that they want us to find any term in this sequence, we're just going to take the previous term and add 5. Right? So we're just reading the rule and being like, oh, they just want us to add 5 every time, right? So literally to get from one number to the next, right, we're just going to add 5, which is why they had to tell us the starting number, or else we would have no idea where to start the sequence. So clearly -3 plus 5, is going to give us 2. Then we're going to add 5 again. Then we're going to add 5 again. And the question did say find the next 3 terms, right? And so this is going to be our answer. Okay, and I just want to remind you, whenever you're adding or subtracting to get the next number in line, remember this is an example of an arithmetic sequence, right? When we add and subtract. Okay, all right. Over here on this next one, it's basically kind of the same thing, right? It's still a sequence, so it's still a list of numbers. So I'm just going to start by drawing some blanks, right? Now this one says if a sub 1 is -3, okay, same number, -3. It's a weird looking 3, let me fix that. There we go. All right, so we're also starting with -3, but then we need to go read his rule, right? His rule is telling us to, in order to find each term, we take the term before it and we multiply by 2 is what that's telling me to do. Multiply by 2. So I'm going to take my first term and I'm going to multiply by 2, which is going to give me -6. Right? Then I'm going to multiply by 2 again. And you don't have to sit here and write all the loopy things if you don't want to. Right, I'm going to multiply by 2 again, so I'm going to get -12. Right, then I'm going to multiply by 2 again, and I'm going to get -24, etc. Right, and the question did say find the next 3 terms, and so these are our next 3 terms. Okay, all right, so just being able to read the rule. And remember, we call this a geometric sequence, right, when we are multiplying to get to the next number in the pattern. Okay, so adding and subtracting is the arithmetic sequence. Multiplying is your geometric sequence. Okay, and then our last little section is domain and range, right? This is what we talked about all day in class last time. You'll notice I'm giving you 2 examples here. There's also on your quiz, there's also mappings, there's tables, right? Every single representation is on your quiz. I'm just doing graphs right here, so please go look back at your notes if you need a refresher on what a mapping is. Remember, the mapping is with the 2 ovals, right, where you have the lines. So if you need a reminder of what mappings are, I would go back and look at your notes. Okay. All right. So this is domain and range. Clearly, this is a discrete graph because my dots are not connected. So I am not if my dots were like connected, well, then this would be continuous data because I would be including all the infinite decimals in between, right? But this is clearly a graph that is only these 6 points and not all the spaces in between these 6 points. So this is discrete data. And so we want to write the domain and range, right? So basically, when it's discrete data, we're literally just writing a list of all the x values. Now, I will give you a heads up. Remember when you're listing domains and ranges, you have to put them in numerical order from least to greatest, and there are no repeaters. Okay, so you can kind of do this however you'd like. I might suggest that if you have a graph, you just kind of write the coordinates down for yourself. So like this is negative, this point right here is what? -4, -2. And this point is -2, -1. This point is -2, 1. This point is 0, 4. This point is 1, 1. And this point is 3, -1. Right? So that way, when I'm doing domain, right? Remember, domain, this is my domain, right? Domain is the set of all the x values. So I'm literally just going to go look at what all the x values are that those points take on, and I'm going to write them from least to greatest, which means from left to right, and I don't want to list any repeaters. So from left to right, my domain is -4, right? That's this guy right here. He's my lowest x value. Then I have 2 points that have -2, but I don't need to list it twice, right? I don't need any repeaters. Then I have an x value of 0, and then 1, and then 3. Right, and so that would be the domain of this discrete data because I'm literally just listing the x values in order from least to greatest with no repeaters. Okay, then we want the range. I'm trying to color code it here. And remember, the range is the height of the graph from low to high. And again, we're just listing the y values. So I would suggest, there we go, make it a lighter color here. Right? So from low to high, this is my lowest point. Then I have a -1. I have another -1 over here. And then I have a 1. Oh, and then I have another 1. And then I forgot about that 4 up there. Right? So range is always from low to high because it's least to greatest, right? So when you're doing range, it's always from bottom to top. So my lowest y value is -2. My next lowest y value is -1, which appears twice, but I just write it one time. And then my 1s appear twice, but I'm only going to write them once. And then my 4 up top. And those are my y values from least to greatest. Right? And so this is how we're going to do domain and range from a graph. Okay? Now that's only if my data is discrete. Over here, my data is clearly continuous because I'm not only talking about the endpoints, I'm talking about all the infinite fractional values that exist between them, right? So there are infinite points that exist between those two endpoints, right? And so we got to capture all of them. Okay, so this is continuous. Continuous, making sure I spelled that right. All right, and so if it's continuous, that means your domain and range is either all real numbers, if it goes forever, on and on and on, or you're going to have to use inequalities, right? And so clearly this graph doesn't go on and on and on forever because there's not arrows on the end, right? There's actual dots, okay? So here we go. Our domain. All right, so we need remember, domain is how wide our graph is, right? And so if I were to, I'm going to kind of, I'm going to draw a box right here. So if you remember how we talked in class, hold on, sorry, I'm going to change my color really quick. Okay, I'm going to use yellow. All right, I'm just going to draw a box around here. Oh my goodness. Okay, never mind. I'm changing my mind yet again. Okay, so remember how we talked in class, right? That if I'm going to put boundary lines, right? This function does not exist, and it only exists in between these two x values, right? And so it's picking up every single value in between those two boundary lines. So we just need to know what those x values are. So clearly this is an x value of -3, right, on the x-axis, right? And this is an x value of +3. So we want to include all the x's, right, between -3 and 3. So remember, we're doing this. We want all the x's between -3 and 3. So we're going to write it just like that. We're going to do -3, x, and then 3. And if x is between -3 and 3, then we're going to use inequality symbols, which will always be less thans, right? Because we're writing things from least to greatest. So the furthest left thing is less than all the x's, and the x's are less than all the 3's, right? So we're going from least to greatest, so they have to be less thans. Okay. Now the only other thing we need to analyze is, are either one of these less than symbols, are they going to have the equal to bar? Well, clearly on the -3, it's an open circle. So no, because open circle means that's just my stopping point, but I can't actually land on it, right? And so I can't actually equal -3. But then this guy has a solid dot, which means yes, we are actually going to land on the +3. Okay, so we want to use that. All right, so that's our domain. All right, I'm going to erase this. Okay, now let's talk about our range. So remember, the range is the y boundary, right? How tall is the graph from low to high? So again, I'm going to kind of make my boundary lines. And I'm going to analyze my y values, right? So here's all my y's, right? And my graph is existing height-wise between those two blue lines, okay? So this is a y value of, man, I've got a lot of lines going on here. This is a y value of 2, and this is a y value of -1. And so from low to high, right, all of my y's are existing between -1 and 2, and that's exactly how I'm going to write my inequality, -1 to 2. And again, then I just have to ask myself, are there any equal to bars? So I go to my low point right here. Can he actually equal that -1 value? Yes, right, because that's a solid dot. But then I go up here to that +2 value, and that's where that open circle is, right? So that's going to stay just a less than symbol with no equal to bar, right, because we're not equal to with that open circle, okay? Again, I know that's a lot. That's why we want to use our highlighters like we did in class, or use the Post-it notes like we talked in class. Okay, anything that helps your eyes just look at the width or the height of the graph only. Okay, and there you have it, right? So just a quick little review of all those topics that are on our quiz on Monday. Okay, again, none of them require a lot of actual like math work, right? But you do have to know a lot of vocabulary and notation, and just how to read instructions and what it's asking you to do. Okay, which again, all comes back to vocabulary. Okay, so make sure you're looking back at your notes. I just wanted you to kind of see a hint of everything that you're going to run into on your quiz Monday. Okay, see you.